Record, share screen. Perfect. All right, today's the 25th. 1/25/23. Oh, the date is green today. How exciting. Look at that. Forgot to switch to my white pen. So we embark now on a brand new section. You'll see an entire new section now in Canvas, a new module, logarithms. I assume I put it in there. I might have put it in the old one because I'm kind of a dingbat, but I'll fix it for sure. So today you're going to learn how to do something called evaluating logarithms. This takes time. Really becoming comfortable with logarithms takes time. There's no quick road. But today we're going to stick to one very kind of basic idea. We're not going to branch out. We're not going to talk about properties of logarithms. We're not going to do equations with logarithms. We're just basically I'm going to give you a log and you're going to figure out what the answer to it is. It winds up being almost as easy as like, oh, what's 3 times 6 or things like that. You'll see. So I decided before we actually get into the lesson that I need to put a math problem up here and see if you guys know what the answer is, because you come to me from different places. And I know that especially if you skipped 8th grade math, you might not have seen a full thing on properties of exponents. So I'm always curious. And by the way, the answer is not -9. Let's get that out of the way first. Do you guys know what 3 to the power of -2 is? It is exactly 0.1 repeating. But why? Why is that? Kinda. Would you believe me? Would you think I was crazy if I told you the answer was 1/9? It is. Try to make a connection there, because I don't think we've ever talked about negative exponents. It's certainly not worth a whole day. It's worth 5 minutes, and that's what we'll give it. So how do you think I arrived at the conclusion of -9? I squared it and stuck it in the bottom of a fraction. Very good. So maybe then if you're looking at my TV like, what did he just say? Let's try another one, and then you see if you can connect the dots. So what if I gave you 4, but I told you I wanted to go to the -3rd power? And you got to get the idea of the answer is going to be negative. You got to kick that right out of your brain straight away. Get it gone early. Don't let it come back. What's the answer? It's 1/64. Very good. So what's happening here is I'm evaluating the powers, but I'm evaluating them in the bottom of a fraction. Negative exponents are actually pretty wimpy. They serve one role, and that is to simply take things that are upstairs and move them downstairs. It was upstairs, it went downstairs. And of course, you understand that what we're doing downstairs is just 3 to the 2nd power or 4 to the 3rd power, right? So let me give this to you in a generalized format. I'm going to give it to you now so you can't actually turn it into a math problem. What if I gave you x to the power of -5? What's the answer? That's what we do. So there is a nice sort of generalized version of this math problem for you, which basically says, if you give me something with a negative exponent, I'm going to do something called reciprocate. That means in math, that's a fancy way of saying flip it over. So it used to be, let me show you, I'm going to write in yellow for a second. Like this used to be over 1, and this used to be over 1, and this used to be over 1. And what's happening then is the meaty part of the problem is going to the bottom. Okay. So that's all a negative exponent has the, pardon the pun, that's all it has the power to do. So, sorry, Jared, it was my bad. So having said that, now let me come at you from the other direction and see how you handle this. What do you think 1/4 to the -2nd power is? Your heart was totally in the right place. The answer is, of course, I did not expect that. I expected lots of answers, but not for you to miss 4 times 4. Good job. The answer becomes a whole number now, because in the same way that a whole number gets reciprocated to the bottom, a fraction gets re-reciprocated. You see what I'm saying? So like the 1 and the 4 basically get reciprocate flipped, and then you square it once the exponent's positive. So that flipping process is what makes the exponent become positive, and then you just do the math, right? But this one, the answer is 81. Very good. And of course, conversely, what is 3 to the regular, just regular 3 to the negative 4? That becomes 1 over 81. So really all we're doing here with negative exponents is playing a little childish game of flippity-do. We're flipping things over, flipping things over. So fractions become whole numbers become fractions. Negative exponents are not scary. You just have to understand that they don't make things become negative. They make things flip over, flip, 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 right? Here's another one, and I'm always curious to see the answers that I get. And then once we get past this, then we'll actually get into talking about what we're doing today. These are what we call prerequisite skills. So what if I gave you 4 to the power of 0? You would think so. It is actually 1. Okay. And I can show you really quickly. I just want to give you a little bit of background as to how that could possibly even make sense. So let's say I made a table of, so by the way, what is 2 to the 0th power? 1, right? Anything to the power of 0 is 1. Some people say, well, why is that? Like, I'm calling BS on that. That doesn't make any sense. Well, let's make a little table here. This was the best explanation that I ever got, and I have considered it my duty to pass this on to the students that I meet. So this, to me, the moment I saw it, I went, I'll never wonder why that works again. So here it goes. So what is 2 to the 5th? What is 2 to the 4th? What is 2 to the 3rd? What is 2 squared? What is 2 to the 1st? Now, it's undeniable in this case why the next answer has to be 1. Take a look at the pattern that's emerging in the exponents. So we go 5 minus 1 minus 1 minus 1 minus 1. So if that pattern holds true, so too then should the pattern in the outputs. Divide by 2, divide by 2, divide by 2, divide by 2, divide by 2. 2 divided by 2 is 1. You can do that for any number. If anyone ever wants to ask you, like, hey, could you explain to me, like, how is it that anything to the power of 0 is 1? This would work for 5s also. Let me switch colors here and show you. We could do like, what's 5 to the 4th? Oh, that's 625. What's 5 to the 3rd? That's 125. What's 5 squared? You see that every time, and I mean literally every time, we're dividing by the base. We divide by the base, 5 in this case. Last time it was divide by 2. And so the pattern is just irrefutable, that the inevitability of this is that if I keep dividing by 5, hey, guess what I get? 1. It's going to keep happening. And so that's the best explanation I can possibly offer you as to why that is. But what you need to take away from this today is that anything to the power of 0 equals 1. It does. Would you like to see what it looks like after 0? Because I'd like to show you. Let's continue the pattern. I'm going to draw a line here at 0, and we are now heading into the world of negative powers. So Jared asks a very important question. If I continue the pattern to 2 to the negative 1st, right? That would be next. What should I get for my answer? Because that's 1 divided by 2, right? You see it, Jared? If I go again to 2 to the negative 2nd, what do I get? I divide by 2. And remember, dividing by 2 really means to multiply the bottom of a fraction by 2, which gives me, hey, 1/4. And didn't we just see a connection to this, that if something has a negative power, doesn't it go to the bottom? Does that make sense to you, Jared? The nodding of your head tells me that was a pretty sincere yep. So you see the connection? So yes, the pattern definitely continues. Good. Exponents are neat. All they really are is repetitive multiplication. If you think about it, if I'm repeatedly multiplying something by itself, as I shrink my exponents, then I'm repeatedly dividing by itself. And that's why we would do that. So good, good. All right, so you have all the prerequisite knowledge now to get through the next part. So now we're going to introduce something that you should not have ever seen before. I don't think it gets touched in algebra. I know it doesn't get touched in algebra 1 or anywhere else for that matter. So I'm going to, like I do a lot of times, I just, rather than talk a lot about fancy definitions, the best way to learn math is just do it. I'm a big believer in that. Just do it. So I'm going to put a problem up here. And for the first time now in your life, you're seeing what's called a logarithm. This is a statement, and I'm going to tell you how we say this because you and I are going to be saying this to each other a lot in the coming weeks. We call that, bless you, we say log base 5 of 125. Log base 5 of 125. And I'm going to tell you that the answer is 3. I'm going to give you another one, and I'm going to put log base 4 of 16. And I'm going to tell you that the answer is 2. I'm also going to do another one, and I'm going to say log base 6 of 1 equals 0. I'm going to give you another one. I'm going to say log base 8 of 512 equals 3. These are, I'm not toying with you. These are factual statements. It would be no less true than if I were to write, oh, 2 plus 2 equals 4. 3 times 4 equals 12. These are math facts. And I heard Alyssa make a noise right away on the first one. Did you guys crack the code yet? Do you see? A logarithm is an exponent. So when I asked you for like, and I didn't actually ask you, I just bullied you and wrote them down. But on the very first problem, if I had stopped here at log base 5 of 125 and said, evaluate that log. Trust me, when you walk out this room today, this is going to be as easy for you as 2 plus 2. What I'm asking you when I say what is log base 5 of 125 is I'm saying this. What exponent would you need to put on a 5 to turn it in to 125? The answer is 3. Same on the next ones. And we're going to, I call it the water circle diagram. And I don't know why. I guess I do know why. Kind of, in science, like the little arrow diagram, how the water goes and it goes up in the sky and then it falls down. And you know what I'm talking about? You've seen that? So here's, to me, the way logarithms work. This to the this equals this. You see how it kind of just looks like a little water cycle? That's the foundational piece of a logarithm. These are what we call logarithmic equations. They're not equations in the sense that we have to solve them. They're just equations because they have equal signs. But every logarithmic statement can be written as what we call exponential. So for example, the first one I could write as 5 to the third equals 125. And you agree. Of course you know that. How would I write the second one exponentially? How would I write the third one exponentially? A fact. How would I write the last one? Good. Really embrace that water cycle diagram. It's the crux of this entire next unit is that base to the power of logarithm equals this guy. And that guy has a name, and I'm going to give it to you here in just a minute. Do you have any questions so far? So I'm going to put up a couple of logarithms and have you evaluate them for me. You should have no troubles with this at all. So let's do log base 9 of 81. Let's do log base 2 of 64. And let's do log base 5 of 625. 5 minutes ago, that would have made literally 0 sense. At this point now, hopefully the code is cracked and you realize I'm just asking you to play a game of fill in the blanks. So what is the answer to the first one? It is. What is the answer to the second one? It is. And what's the answer to the third one? It is. So again, when I ask you to evaluate a logarithm, I'm really just asking you to find an exponent that's required to make something happen. Is everybody up to speed? Yeah. I want you to know a word, and I want you to put this in your notes. This number, the number we're trying to make, basically, get used to saying this. I need to do a better job. I decided this year I need to say this on day one. That is called the argument of the log. I know that sounds weird, but you're going to hear me talk about that a lot. Like, what's the argument of the log? And you need to bear in mind that that's what I'm talking about. Okay. So if you want more vocabulary, which you probably don't need these ones, but just to be safe, what do you think that 9 is called? That's called the base. You already, I think, knew, you heard me say that. And then what is the quote unquote answer called? It's actually called the logarithm. So basically, those three things, the base goes to the power of the logarithm and equals the argument. That's the relationship that we're coming up with here. Okay, I'm going to branch out a little bit more, and here we go now. Let's try this one. Let's do log base 6 of 1 over 216. This is why the first part of today's lesson was so critical, is because you can totally do this. You're like, wait a second, there's a fraction as the argument of the log. How possibly could I raise 6 to a power, use a negative logarithm, a negative power? Yes. So what is the answer to log? You guys are good. -3. Pablo, good? I think I have, I think that's basically, I think, all I needed to say. So do you guys at this point feel like you can evaluate logarithms? Let me take a look at your worksheet and make sure that, because I have a tendency to brush past things. No, I think that's it. That was more efficient than I actually thought it would be. I'm proud of myself. I think you know everything you need for day one. So I'm going to end the recording. I'm going to hand this out. This is 20 questions. I honestly would be surprised if the whole thing takes you longer than 10 minutes. I'll be massively surprised if you're not done before the bell rings. So, enchilada is the magic word. Enchilada. Yes, if you come back to my class, if you're one of the people that stayed home today, Wednesday, January 25th, the magic word is enchilada. Prove that you watched the video. Enchilada. I'm not even going to write it on there. I'm just going to, should I write it on there? No, because they could fast forward all the way to the end, right? Yeah, enchilada. I don't know.